Okay, so today we're going to teach about stoichiometry. It is the calculation of the amounts of reactants and or products in a chemical reaction. An example of a stoichiometric calculation is the combustion of methane into carbon dioxide and water. You need 1 molecule of methane, 2 oxygen gas, then it yields 1 carbon dioxide and 2 molecules of water.
What do you mean?
An example of stoichiometry is a mixture of hot cocoa. 1 cup of H2O and 5 tablespoons of hot cocoa mix equals 1 cup of perfect hot cocoa. Time for an example of the stoichiometric calculation of hot. We have 1 cup of H2O.
Then we have 5 tablespoons of hot cocoa mix.
Each scoop is equal to 2.5 tablespoons. Yum.
This is truly the perfect cup of hot cocoa.
The same calculation for a chemical reaction now. Carbon monoxide reacts with oxygen to produce carbon dioxide. There are 2 carbon monoxide molecules needed to react with 1 oxide molecule.
2 moles of carbon monoxide needed to react with O2 to produce 2 moles of carbon dioxide.
1 mole of O2 needed to produce 2 moles of carbon dioxide.
Beginning with 6 moles of carbon monoxide, how many moles of carbon dioxide will be made if all of the carbon monoxide is used up?
From the equation that we need 2 moles of carbon monoxide to produce 2 moles of carbon dioxide. As shown in the stoichiometric calculation. In a stoichiometric calculation, you cancel out like terms. In this case, we have 6 moles of CO, which we can cancel out with 2 moles of CO. And we're left with 6 moles, 2 moles of CO2 over 2. The mathematic solution to this would be 6 moles of CO2, which is come from 6 times 2, which equals 12, divided by 2.
One less problem without you. I got one less problem.
Moles of O2 will be needed to react with 6 moles of CO.
We start with 6 moles of CO. We know from the equation that we need 2 moles of carbon monoxide to react with 1 mole of O2 to produce 2 moles of CO2.
In this equation, we would cancel out the moles of CO again. And that would leave us with 3 moles of O2.
So there are 3 moles of O2 needed to react with 6 moles of CO to produce 2 moles of carbon dioxide.
One less problem without you. I got one less problem without you.
How many moles of carbon monoxide are needed to produce 7.50 moles of carbon dioxide?
In this equation, assume that you have an unlimited supply of O2.
With 7.50 moles of carbon dioxide, we know that 2 moles of carbon dioxide are produced for every 2 moles of carbon monoxide. That will leave us with 7.50 moles of carbon monoxide that is needed to produce 7.50 moles of carbon
Thank you for
dioxide.
watching our video. We hope that it will help you with future stoichiometric calculations.
Is it too late now to say sorry?
Carbon dioxide. In this example, we're using 1 cup. In order to make a cup of hot chocolate, you must mix.
It doesn't look like that.
Well, I think you have to put more scoops.
No,
Well, it's because it's not milk, it has to be milk.
no, maybe it's supposed to be hot.
Oh yeah, can you microwave this?
Let's microwave it.
This tutorial will help you learn stoichiometry and understand the fundamentals of stoichiometry.
This is practice what we're gonna say.